meter measurement. The objective of the experiment is to compare the accuracy between three types of flow meter. The first flow meter is this one. It's using an Orifice, and this is the electromagnetic flow meter using a magnetic field. And this is a Coriolis flow meter, which uses Coriolis effect to measure the mass flow rate.
Hi guys, my name is Muhammad Arif. Today I'm gonna talk about the process flow in the system. For the flow is come from the tank, and here, and then the flow will go up to the pipe, pressed by the pump there, and then go there and open this valve to allow the flow goes to the flow meter. And then here we got three pipes containing three different flow meters. So, for example, if you want to use the Orifice flow meter, open this valve and close this valve, and make sure these both are closed to allow the water go through here. And this valve also open, and then the flow will go up to the calibration tank. For this experiment, we want to measure the flow rate of different flow meter, which is Orifice flow meter, magnetic flow meter, and Coriolis flow meter. So for instance, when we take 5 liters per minute, we measure the time taken for the water to reach the level of 25, 50, and 75 flow rate of each Orifice meter, 20 to 5, 10, and 15 meters per minute.
Next, the reading of the flow meter is recorded here from the control panel, which is the process variable. The time taken to fill each interval, 25 meters interval, until it reaches 75 meters inside the calibration tank will be recorded. To calculate the flow rate, each 25 meters of water will be divided by the time recorded. In conclusion, flow meters are devices that measures the amount of fluid passes through them. Thus, different flow meters have different functions and measuring variables that can affect the flow rates of fluid.
Electromagnetic flow meters is a volumetric flow meter, which is ideally used for wastewater applications and other applications that experience low pressure drop and with appropriate liquid conductivity required. So, the working principle of magnetic flow meters work based on Faraday's law of electromagnetic induction. A magnetic field is generated and channeled into the liquid flowing through the pipe. Following Faraday's law, flow of a conductive liquid like water through the magnetic field will cause a voltage signal to be sensed by electrodes located on the flow tube walls and sent to a transmitter, which calculates the volumetric flow rate based on the pipe dimensions. A Coriolis flow meter is a mass flow meter. Many applications for Coriolis mass flow meters are found in chemical processes where fluids can be corrosive and otherwise difficult to measure. Coriolis flow meters work on the principle that the inertia created a fluid flowing through an oscillating tube causes the tube to twist in proportion to mass flow rate. Many Coriolis flow meters have two tubes. They are made to vibrate in opposition to each other by means of a magnetic coil. Sensors in the form of magnet and coil assembles are mounted on the inlets and outlets of both flow tubes. As the coils move through the magnetic field created by the magnet, they created a voltage in the form of a sine wave. These sine waves are the key to measuring mass flow. The integral orifice meter is a differential measure flow meter. A differential pressure flow meters are generally applicable to many flows in most industries, such as mining, mineral processing, pulp and paper, petroleum, and also chemicals. Differential pressure flow meters use Bernoulli's equation to measure the flow of fluids in a pipe. Differential pressure flow meters introduced a constriction in the pipe that creates a pressure drop across the flow meter. When the flow increases, more pressure drop is created. Impulse piping routes the upstream and downstream pressures of the flow meter to the transmitter that measures the differential pressure to determine the fluid flow.